doing today?
Good.
All right. You ready for a little bit of science today?
Yeah.
A little bit of entertainment, a little bit of education, a little bit of learning, a little bit of fun?
Yeah.
All right. Oh, you guys don't seem actually awake, but hopefully by the end of this, you guys will be ready for it. I thought we'd talk this morning about chemistry, which is an absolutely fantastic topic. Not quite as cool as physics, but it's okay. All right. And it can be thought of in many different ways, but really, chemistry is a change. Right? It's putting different products together, or different items together, and getting new products. All right? So if I have two little changes that happen here, I want to know which one is physical and which one is chemical. And we're going to get down to it. All right? So I'm just going to take a little lighter here to enable a reaction and a little change. I'm going to have one little bundle of paper changing in one way, and I'm going to have another little bundle of paper changing in another way. So I've got one going. Look at that. Okay, definitely. There we go. We've got a change happening. And here I've got another change happening. Look at that! Oh, look at how amazing this is! Are you in awe?
Wow.
Woo! Yee! Ah! Okay, that was cooler. One of these is physical and the other one is chemical. Which one is chemical? Which one do you think, bud? The one with the fire! Why do you think that?
Because a physical one means that you're like sort of doing it with your hand, with your body. No.
Okay, cool. So I can definitely make a physical change by tearing it up. And when I do that, is this paper actually different? Is it something new?
Yeah.
Or is it just smaller pieces?
Smaller pieces.
That's it. That's all it is. That's just a physical change. It's nothing new. Here, we've got something new. We've got gas that's coming off of it. We've got embers, and we have fire. And we've got an entirely new product. Stop burning, because I'm taking you and putting you away. All right. So there we go. We've got a physical reaction and a chemical reaction. If we take a look at what actually happened there, with one we had paper, and we mixed it with oxygen, and we provided heat. And that gave us carbon dioxide and water. It gave us a new product. And you can actually see something floating around in the air. Woo! When we had paper and we ripped it out,
It's scary.
did we get something new? Did we get anything new? I'm not going to be scared. Don't worry about it. All right? I'll stop being scary if that's the case. All right?
That's something.
Did we get anything new when we ripped out the paper?
No.
No! Oh, he's emphatic about that. No, we did not get anything new. We just had paper in smaller pieces. All right? So there's nothing fantastic. I'm just going to take that and move it aside. All right, so let's take a look at what are actual signs of chemical reaction. So to know if there is a chemical reaction happening. Do you guys know any signs, any idea what would make you think there's a chemical reaction going on? Yeah. So if it's changing, and you said, for example, a color change, that's absolutely fantastic. Yeah, color change is a good sign. It doesn't guarantee it, but it's a good sign. Does anyone else have another sign? Talk to me. Temperature change! Wow! You're good! You're not cheating at all! That's fantastic. It's not cheating if you know where to go for the information. Don't worry about that. That's great. Is there anything else? Yeah? Let's go to gas. If we have a gas, well, you know what? I'm just taking that away now. All right? Yes, if we have a gas, if you have heat, I don't know if we mentioned that, or precipitate, and you have light being emitted. All these are signs that there's a chemical reaction that's likely or possibly happening. So we're going to do a little experiment right now. And we're going to do a little experiment. I want to know if it's a physical reaction or a chemical reaction. All right? You guys might have already seen this one. In fact, I hope you did, because that means you're doing your homework at home. It's already classic, even though it's only been around for a few years, that I know of. That's really hit mainstream popularity. It's called Coke and Mentos. You've probably already seen it. You've got an idea. Who's got an idea what Coke and Mentos actually does? Okay. Or at least you've seen it. Well, here's what we're going to do. I'm going to take some tonic water, which is definitely different than Coke, but essentially the same thing. I'm going to open it up, and I'm going to hope it doesn't... No, spitting on me. All right, there we go.
Pop.
I'm going to add my little Mentos dispensing system.
Get wet or no?
You're not going to get wet. You don't need to worry. Unless you want to help me out.
I'll help you out.
Come on, just give me a second. La la la. La 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 la. La 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 la. Okay, I'll put your phone too while I can type it. Who wants to help me out? Who's actually interested in helping me out?
Me.
Alright, you come on down. Leave your phone there though.
get
I don't want
recorded too.
No one's going to get wet, except for maybe the guy I just picked. All right.
He going to get wet?
Doesn't exactly look straight, does it? Is that perfect? Now here's the thing. We've got a liquid. We've got gas all around. We've got a solid. We're going to mix them together. We're just going to see what actually happens. But I'm not quite done yet. Come on, bud. What's your name? Winston? Okay. Listen, I'm going to bring the lights down all the way. I want you to come over here. I'd like you to plug this light in. Let's do it. Plug it in right there. Perfect. Okay, now that's weird. It obviously wasn't that color beforehand, but now we've turned on a UV light, a black light, and it's projecting on it, and we get to see all kinds of awesome colors. Isn't that great? So great! Yes! Chemical reaction! We have the emission of light! We have light, and there's color change! That's great! Now here's what I want you to do. I want you to come over here. I want you to pull out that little rod, and I want you to back up. Back up. Uh-oh. Ah! Okay, well now you're just messy, dude. Okay. Why did you jam me so much? Well, that's just messy. Uh-oh. All right, most of the gas is out. I think I'm good.
I don't want to get wet.
No, dude, it's good. Let all the gas out. All right, there we obviously had a little messy reaction, which is a great one to do outside. And trust me, when you do it the right way, it makes quite the large mess. All right? But what's going on? Why is it? Hey, look, it's glowing! It's glowing! It's glowing! Okay, no, but seriously, it's glowing. Come on, look at it. Don't you see it? It's glowing. No, it's glowing right here. Don't you see it? So we just had a reaction happen. We just had a change. Was that a chemical change or physical change? I would like everyone who thinks that was a chemical change, I would like you guys to hit your hands on the rail. Hit your hands on the rail if you think that was a chemical change. If you think that was a physical change, stop your feet on the ground. Stop your feet on the ground. Stop your feet on the... No one? Everyone thinks that's a chemical reaction? Yes. Well, here's the thing. Although it does have signs of a chemical reaction, there is a color change. There is a emission of light. Winston, would you mind unplugging that light? Because yes, we have all those different signs of chemical reaction, but they really don't have... Wait a second, the light went off. They really have nothing to do with the reaction at all. All that really happened in that reaction was gas was released. Right? Again, another sign of chemical reaction, but it doesn't guarantee that it is one. I'm going to talk about that right about now. Let's give Winston a big round of applause for making a horrible mess. Thank you, Winston. Also, I'll give him a real round of applause. Coke and Mentos, although a lot of people think it's a chemical reaction, it's actually a physical reaction. You're not getting a new product when you put them together. All you're doing is releasing something that's already there. In pop, it is a liquid. It is a beverage, but it's also carbonated. It is filled with gas, carbon dioxide gas. And that's what fizzles when you take it and it goes on your tongue. All right? That's what makes that interesting tingling sensation. There is gas in suspension or in solution in this liquid. All right? But as soon as we drop Mentos in, what's really cool is although we think of Mentos as smooth, if you look at them very, very closely, they're actually pitted. That's a Mentos magnified to 40 times. They're actually got all kinds of little ridges and bumps on them. And what happens is as soon as you put them into the tonic water or the Coke, the gas that's in the liquid grabs on. Ah! It grabs onto all those little pits and grooves, and it turns back into gaseous state. And it happens so quickly, with so much area, that all the gas tries to rush out at once. And when it does that, it shoots up in the air and makes a giant mess. An even bigger mess if things don't get clogged. But that's how it works. If you notice on the thumb right there, it's all, you can see bubbles forming. That's what's called nucleation. Those are nucleation sites. It's sites where the gas can actually go back to its gaseous state.
So trying to
and
rip
it doesn't
your thumb
happen
open.
so much, all right, so quickly, it actually rushes out incredibly fast. It is not a chemical reaction. It's actually just a physical change because the Mentos are still here. You might see them in the bottom of the jug. All right, the liquid is still here. And the gas is still around. It's just rushed out. So to know whether something's a physical or chemical reaction, you have to look at not just the sign, but you got to sometimes figure out what's actually happening on a smaller level, on a molecular level. So what we're going to do is we're going to do another little reaction. I'm going to get this. Would you like to help me out? Come on in. I'm going to move this over to the side. If it starts to fall, let me know.
It's starting to fall. It's starting to fall.
All right. Did you stand yourself in front near that spot? We just saw a physical reaction that demonstrated signs of chemical reaction. Here we've got two liquids that are essentially clear. One's got a slight color to it, maybe a little yellowish, but really they're clear, right? Why don't you take one in that hand? Oh, I guess I'll do one. Okay. Or do you want to do both at the same time? What I want you to do is don't break the glass. I'm going to go turn off the light, and I want you to slowly pour them both into the funnel. I don't want it to overflow, but I want you to pour them slowly both into the funnel. I want you guys to watch it.
Dude,
There, you can go a little faster.
that's cool.
Now that is cool. And now we have light being produced. This light, this black light that provided our light before is off. It doesn't have anything to do with it. Here we've got actual energy being kicked out in the form of light. Is that a physical reaction or a chemical reaction? That's definitely a chemical reaction. Isn't that cool? Essentially the same thing that's happening in the glue sticks that you break. And you're mixing two chemicals together. And what's happening is it's getting juiced up, and then it drops down, and it kicks off the extra energy in light. Can we give this guy a big round of applause? Thank you. So now we do exactly have that. We have a chemical reaction. We actually have a new product. If you give it a second, oh, actually already, you're going to see that it's sort of browning. It's oxidizing. All right?
Brown.
So to know what's happening, to know if it's a chemical reaction, you sometimes have to go and look at the really small level, all right, the molecular level. And you have to deal with what are called atoms. And an atom is essentially part of the foundation. It could be made up of, it's made up of smaller things, but it's the foundation of everything that's built up around us. All right? And it's made up of pieces in the middle. You might see they're kind of expanding in the middle. Those are protons and neutrons. And on the outer edge, you have what are called electrons. All right? They're spinning around. And there's a lot of energy in those atoms. There's a lot of movement. Now, what happens is sometimes these atoms, these electrons, actually hop around. And sometimes they'll go latch onto another atom. Sometimes they'll just hop up to another level and drop back down. But there's all sorts of energy here. There is energy in this movement. And that's what makes the chemical bond. That's what makes the chemical reactions actually happen. So here's what we're going to do. We're going to talk just a little bit about whether these chemical reactions actually happen around us. Chemiluminescence, or actually bioluminescence, is called chemiluminescence, but when it's done for biological means, bioluminescence happens in fireflies and even some really, really cool fungi. Not like me, a fun guy, but that sort of fun guy. So what happens is it emits light by kicking the electrons up, and then as they fall back down, there's additional energy there, and it comes out to us in the form of visible light. And chemical reactions really do happen all around us every day. Not only do they happen around us, they actually happen in us. If you take a look there, I started off with a photosynthesis song. Sorry, I'm French. I want to say photosynthesis. All right. We start off with the photosynthesis. What's the word?
Photosynthesis.
Thank you. I'm glad I kept you guys around. All right, the photosynthesis song. All right, and that's an actual chemical reaction. Not only that, it's a chemical reaction that is reversible. All right, we provide carbon dioxide. The plant takes that, gains energy, uses it where necessary, and it gives us back oxygen. All right, we can provide carbon dioxide, it gives us back oxygen. We take in oxygen, we do all sorts of transformations and transfers of energy, and then we give it back carbon dioxide. It happens over and over and over again. And blood cells actually take this oxygen through our body, and then they pick up the CO2, the carbon dioxide, and they kick it out, and it happens over and over and over again. Batteries in the bottom left corner. Who here is using a battery? Huh? Hey guys. Where's your battery? It's in there. So honestly, over the course of the day, I honestly challenge you guys to go without using a